I am discussing JEE Advanced Paper 1, the mathematics section. The first question there dealt with a symmetric 2 by 2 matrix. We know that for a symmetric matrix, I need to have the diagonal entries as this. It was given that each of these A, B and C are integers. We were looking for a situation under which the matrix is invertible. For the matrix to be invertible, it should not be singular. In other words, AB should not be equal to C square. The first and second options there were talking about the first column and the second row being transpose of one another, which would then mean that this equality should come about, which clearly is going to give us A equal to B equal to C, and in which case AB will be equal to C square. So options A and B are going to be incorrect. As far as option C is concerned, you are told that the matrix is a diagonal matrix, which would then mean that C is non-zero. You are also given that the main diagonal entries are non-zero, which means A and B are not equal to 0. Clearly then this inequality is going to get satisfied. The fourth option dealt with a situation wherein the product of these two entries, that is AB, is not the square of an integer. Clearly, if it's not the square of an integer, it can't be equal to C square. Therefore, the correct answer for this is going to be options C and D. The second question, there were two circles given, one of which was specified as x square plus y square equal to 1. The other circle was having its center at 1, 0 and a radius of 4. We were looking for a third circle which intersects both these circles orthogonally and also passes through the point 0, 1. Note that if I have a circle passing through the point 0, 1 and which intersects this circle orthogonally, that clearly tells me that the center of that circle must lie on this line. The center of the circle then would have to have a y coordinate of 1. That is, the center must be of this form. Additionally, if that circle intersects both these circles orthogonally, its center must lie on the radical axis of these two. If you consider the radical axis, you get that the center of that circle needs to be the point -7, 1. So the center is somewhere here, passes through this point. This distance is known to us as 7. That becomes then the radius of the circle. Answer therefore is going to be BC. The next question dealt with three vectors, each of magnitude √2 and the angle between every pair of them being pi by 3. Note that in such a case, if I just consider the dot product of the two vectors, that would turn out to be √2 into √2 into cos of pi by 3, that is 1. Similarly, y dot z is going to be 1 and x dot z is going to be 1. Now the vector that we are looking at, A, was given to be a non-zero vector perpendicular to x and y cross z. So I can then say that the vector A must be mu times x cross y cross z. Using the vector triple product formula, we can state that this must be equal to this vector. What remains then for the various options is for us to determine the value of mu. To determine the value of mu, if you observe the second option, that is dealing with a term like A dot y. If I then take the dot product of both these sides with y, we get that A dot y should be equal to So mu comes out to be A dot y. If you substitute here, that gives us that A should be equal to by absolutely the same logic, we get that B should turn out to be this. And then if we consider A dot B, this is what we'll be having. Note that this and this term are 1, they cancel off. This is 1, this is minus 2. Clearly that gives us the result as therefore the correct answer for this question would become A, B, C. The next question was on 3D geometry, in which you're given that from a point P, which is this, a perpendicular is drawn such that PQ with Q lying on the line, this is being considered. Clearly, if I'm looking at a point on this line, Q must be of the form of this. The line joining P and Q needs to be perpendicular to this line, which then gives us a condition like in other words, then K should be equal to lambda. So the point Q then would have to be lambda, lambda 1. Note that for these two to be distinct points, we clearly require that lambda cannot be equal to 1. If we consider the point R, that was specified as being on the line y equal to minus x, z equal to minus 1, and PR needed to be perpendicular to this line. Following a similar logic as this, we get the point R now to be equal to it was additionally specified that the angle QPR should be equal to 90 degrees. We can then use the Pythagorean theorem for the triangle PQR, or I could just look at the vector PQ and the vector PR. They need to be perpendicular, which would then give me a condition like this being equal to 0. Since we already specified that lambda cannot be equal to 1, we just get that lambda plus 1 should be equal to 0, and therefore lambda should be minus 1, giving us the answer as only C for this question. The next question, we were looking at two functions f and g such that the maximum value of f of x is equal to the maximum value of g of x over the interval 0 to 1. If I then were to consider a function which is the difference of both of this, assuming say that this maximum of f of x comes about when x is equal to c1, the maximum of g of x comes about when x is equal to c2. Note that there could be multiple values of c1 and c2. They may be equal or distinct, that's immaterial here. If I then consider d of c1 multiplied with d of c2, we would find that this comes out to be of which now this quantity is going to be greater than equal to 0. This quantity is going to be less than equal to 0. Clearly then, if the product of d of c1 and d of c2 is either 0 or negative, That tells us then that somewhere in between C1 or C2 or at either of these 2 points, I need to have d of x equal to 0. Or in other words, there is going to be some c for which f of c is equal to g of c. If this happens, by direct substitution, we can verify now that options A and D are going to be correct for that question. The next question was dealing with M and N being two 3x3 matrices, satisfying the condition that Mn is equal to Nm, M is not equal to N square, and M square is equal to N to the power of 4. The various options there were dealing with conclusions about this matrix, M square plus Mn square. Note that this matrix can be written as this one. If I then simply look at introducing another matrix here, wherein this kind of result would come about, we can simply say that I should be looking at a matrix M minus N square. Note that what this becomes now is going to be clearly this term we obtain as 0. As far as this is concerned, note that this is M into N into N, and the next matrix is, if we then utilize this condition, this first matrix can be written as, and similarly this matrix can be written as, both of these then are cancelling off. We are therefore getting this to be the null matrix. If this is turning out to be a null matrix, this is given as a non-null matrix, that is, this is non-singular, this is non-singular, clearly then this matrix must be singular. That is, its determinant must be equal to 0, which tells us then that option A is correct and C is incorrect. Also, there is some mention about a matrix U such that this product into U becomes the null matrix. Clearly then I can take the matrix U as this one or any multiple of this matrix. Clearly this is not singular, this is not a 0 matrix. A multiple of that also need not be a 0 matrix, which tells us then that option B is going to be correct and D is not going to be correct. Correct answer then there is going to be only A. The next question dealt with a 5th degree polynomial like this, and we are looking for the number of roots of this equation depending on the value of A. Effectively, when we are looking to solve this equation, we are looking at figuring out the number of intersections of these two curves. If I consider the equation x to the power of 5 minus 5x, we can easily check up that its derivative is 5x to the power of 4 minus 5, which takes a value of 0 when x is equal to plus or minus 1. Therefore, the extrema of this function g of x would be occurring at plus minus 1. The graph of g of x then is going to be this way, with this value being equal to 4, this value being equal to minus 1. H of x equal to minus a is going to be simply a horizontal line that is parallel to the x-axis. What we then need to consider is, as I move this line along this in this manner, how many times does it intersect the curve that we have drawn? It is then fairly obvious that if a is greater than 4 or less than -4, it would intersect the graph either here or here. If a is equal to plus or -4, there are going to be two intersections here. If modulus of a is between 0 and 4, that is a lies between -4 and 4, then there are going to be 3 points of intersection, which gives us then the answer to that question as B. The next question dealt with a function specified as this. We were required to check out the regions of increase and decrease of this function for t. For that, if I consider f dash x, that is firstly going to be this same function with t being replaced by the upper limit multiplied with the derivative of this, which gives me the term as this, from which I would need to subtract the value of this function when t is replaced by the lower limit multiplied with the derivative of this function, which gives us then and then the derivative of 1 by x is minus 1 by x. You can easily see that this turns out to be which is then going to be positive for all positive values of x. Therefore, this function is going to be monotonically increasing from 0 to 1 and from 1 to infinity. Therefore, option A is correct, B is incorrect. The third part that we are looking at is the value of f of x plus f of 1 by x. If we consider f of x plus f of 1 by x, f of x is dealing with the integral over this limit. F of 1 by x is going to deal with the integral over this limit of the same thing. Since the two limits have got interchanged, these two integrals are going to be negative one another. The sum of both of them then is going to be 0. That gives us then that option C is going to be correct. The fourth option is looking at the nature of this function f of 2 to the power of x. If I take f of 2 to the power of x as u, I can easily see that f of 2 to the power of minus x is going to become 1 by u. And since we have found that f of u plus f of 1 by u is 0, that tells us that f of 2 to the power of x is going to be an odd function. Therefore, option D is going to be correct. The answer for this question then is going to be A, C and D with B as incorrect. The next question was dealing with the function as log of sec x plus tan x whole cube, which we can then also specify as 3 times log of sec x plus tan x. This was being defined over the interval minus pi by 2 to pi by 2, and then we have to consider whether it's an odd function, even function, etc. To check up whether it's an odd function or not, we first need to consider f of minus x. If I replace x with minus x here, we can easily see that this part will become sec x minus tan x. And I know that sec x plus tan x into sec x minus tan x is going to be equal to 1. Log of 1 is 0, which tells me then that f of minus x plus f of x is turning out to be 0. And therefore, this is going to be an odd function. The next part that we are looking at was whether it is a 1-1 function. For figuring out whether it's a 1-1 function, all I need to do is check up whether this is an increasing function or not, as x is increased from 0 to pi by 2. I can easily see that as x increases from 0 to pi by 2, this and this individually increase monotonically. Therefore, the complete thing is also increasing. Therefore, this is going to be a 1-1 function. Again, as x increases from 0 to pi by 2, the value of this quantity sec x plus tan x increases from 1 to infinity. And therefore, f of x is going to increase from 0 to infinity. Therefore, f is going to be an onto function. We have therefore shown all the options A, B and C as correct. D is incorrect. This is then the answer to that question. The next function was dealing with g of x, which was defined as 0 when x is less than a, is defined as the integral from a to x of f of t dt when x lies in between a and b, and which was defined as the integral from a to b of f of t dt when x is greater than. Clearly, if I look at here x approaching a, the upper and the lower limit both become the same. G of a then would be approaching a value of 0. That tells us then that g of x is going to be continuous at x equal to a. Similarly, when I have x approaching b, I find that this limit is going to go from a to b, which is the same as what we have here. These two are again equal. Therefore, g is going to be continuous everywhere. What we then need to check is the differentiability of g at both a and b. Note that g is a constant when x is less than a. It's a constant when x is greater than b. So the left hand derivative at a is going to be 0. The right hand derivative at b is also going to be 0. All we then need to check up is what is the right hand derivative at a and the left hand derivative b, which is going to be obtained by the differentiation of this function as x approaches a or b respectively. The right hand derivative at a then is going to be the differentiation of this function, which comes out to be f of a. So the RHD is going to be f of a. Similarly, the LHD that we have at b is going to be f of b. Additional information that was provided about that function f was that it maps from a to b to 1 to infinity. Clearly that tells us that f of a is going to be greater than equal to 1. F of b is going to be greater than equal to 1. It therefore cannot be differentiable at either of these points. Correct answer therefore is going to be AC. Going on to the next section, similar to one of the earlier questions, here it was given that there are 3 unit vectors A, B, C, the angle between every pair of them being pi by 3, which then gives us the result that A dot B, B dot C, C dot A, each would be equal to half. It was also given that say this vector D, which is A cross B plus B cross C, can be written as P times A plus Q times B plus R times C. Some relationship about those scalars P, Q and R were to be determined. That can be easily obtained by simply considering successively the dot product of the vector D with A, B and C. If we are considering D dot A, this turns out to be just the STP of the vectors A, B, C. D dot B comes out to be 0. D dot C again turns out to be the STP of ABC. If I were to be taking the dot product of it with each of these, this then comes out to be equal to if we are then looking at this term being 0 and these two quantities being equal to one another, that directly gives us that P and R should be equal and should be the negative of Q. Clearly then, the numerical value of the expression which was given as this is going to be equal to 4. The next question had a function which was this, and we were looking for how many common roots that would these two functions have over the interval from 0 to 4 pi. From 0 to 4 pi, if we consider cos inverse of cos x, the graph of that is going to be this way, with this value being pi, this is 2 pi, this is 3 pi, and this finally is 4 pi. The graph of 10 minus x by 10 is going to start with a value of 1 at x equal to 0 and reduce down to 0 at a value of x equal to 10. Note that 10 lies between 3 pi and 4 pi, so that value is going to be somewhere here. The graph that we are looking at then is going to be this way. You can easily see from the graph that this is the first solution, this is the second solution, this is the third solution, thereby there being 3 common solutions to that graph. The next question, we were looking at the distance of a point P from this line and from this line, satisfying the condition that D1 plus D2 should lie between 2 and 4. What was required was the area of the region of all points like this in the first quadrant. If we consider in the first quadrant, the line x minus y and x plus y equal to 0 give us regions like this. If I firstly consider the points which lie somewhere here, that is below the line x minus y equal to 0. If we are then looking for the distance from this line and this line, that would turn out to be simply equal to root 2 times the distance x, or the x coordinate. Since we are looking at that line between 2 and 4, that gives us the x coordinate should lie between root 2 and 2. In this region, we would similarly find that is going to be symmetrically this. The area that we are looking for then is this area, which we can easily get as the area of this square minus the area of this square, which turns out to be 6. The next question was dealing with limit as x approaches 1 of this whole thing to the power of 1 plus root x, if we just simplify the exponent that was there. I can then easily divide each of these terms by x minus 1. Thereby giving us that the limit of this part is going to be minus 8, the limit of this part is going to be plus 1. In the denominator, each of the parts is 1. The limit of this exponent is turning out to be 2. This limit was required to be 1 by 4. Solving this, we get the two possible values of a as 0 and 2. The question specified that we are looking for the largest value of the non-negative integer a. If we are looking at a equal to 2, note that then this numerator term is going to be approaching a value which is negative. The denominator is going to be approaching a value which is positive. The exponent here is not an integer. I cannot have a negative quantity to a power which is non-integral, which is changing. So a equal to 2 cannot be permitted. The correct answer here then is going to be a equal to 0. The next question was dealing with a circle on which there are some end points marked out. Any two adjacent points were being joined by a blue line, and every other pair of points was being joined by a red line. It was additionally given to us that the number of red and blue lines are equal, which would then mean that the total number of lines that we have drawn joining all such points should be twice the number of blue lines. Every pair of points being joined would give us there being NC2 number of lines like this. That equation then can be rewritten as for all these to be turning out to be an integer. Here the only possibility is going to be a equal to 6, thereby giving us the value of the expression a square plus a minus 14 by a plus 1 to be equal to 4, which is the answer to that question. The next question required you to figure out the number of solutions of this, wherein n1 to n5 are natural numbers in an increasing sequence. Possibly the simplest way of going about such a thing is going to be by looking at the various cases that we can have. If I then start off with n1 taking a value of 1, n2 taking a value of 2, n3 taking a value of 3, clearly then I require that n4 plus n5 should add up to 14. I require n4 to be greater than equal to 4, since it has to be more than 3. And since n4 is less than n5, I would require that n4 be less than 7. Obviously then n4 can take values of 4, 5 and 6, which gives me 3 solutions here. If I still leave n1 and n2 as this and take n3 as 4, I now find that n4 plus n5 needs to be 13, n4 has to be greater than or equal to 5, and n4 needs to be less than 6.5. n4 now can take values of 5 and 6. There are 2 such values that we can have. You would be finding now that if you take n3 as 5, there is not going to be any solution coming. The next possibility is that n2 is 3, n3 is 4, in which case the sum of the other 2 quantities we require is 12. This has to be greater than 5, has to be less than 6. There is only one possibility. There are no further possibilities with n1 equal to 1. If I take n1 as 2, n3 as 3, 4, we find now that the only possibility is going to be with n4 equal to 4, n5 equal to 6, only one possibility. The sum total of all these possibilities then is going to be 7. The next question we were dealing with was wherein f of x is equal to modulus of x plus 1. The graph of which is going to be this way. G of x was given as x square plus 1. Okay, let me take this up again. F of x was mod x plus 1. The graph of that is going to be this. G of x was x square plus 1, whose graph is going to be this way. The function that was being considered was the larger of f of x and g of x when x is less than or equal to 0, which is then going to give us this graph, and it was the smaller of the 2 functions when x is greater than 0, which is then going to give us this graph. You are looking to identify the number of points of non-differentiability, which is then going to be this, this and this point, thereby giving us 3 points of non-differentiability. The next question had this expression. What was required was the slope of the tangent at the point 1, 3. All we then need to do is differentiate this and put x equal to 1 and y equal to 3. Firstly, when I differentiate this, I am going to get 2 times this quantity. So that is going to become 2 times 3 minus 1 to the power of 5. I would then need to differentiate this. The differentiation of y is dy by dx, that is the slope of the tangent we are looking at. Minus the derivative of this is going to be 5 times x to the power of 4, which is this. On the other side, I need to differentiate this as a product. If I am differentiating this term, this remaining as it is, that is going to be this much. Plus I would have this term, which is 1, into the differentiation of this quantity, that is twice of 1 plus 1 square, and then differentiation of 1 plus x square is going to be 2 times. All the values here are known. We then get the slope of that tangent as 8. The next question was dealing with the integral of this. Note that when I put x equal to 0, this expression is going to be 0. When I put x equal to 1, this expression is going to be 0. If I then integrate this twice by parts, that is by differentiating this function and integrating this function, both the times I am going to get this term as turning out to be 0 for the lower limit, this term as turning out to be 0 for the upper limit. And therefore this integral will just turn out to be and when you integrate this twice, you will be having in this, if you are to now put 1 minus x square as t, this 2x dx is going to become dt. This is then a straightforward integral whose value then would turn out to be equal to